What is the difference between mass and weight? Mass is the measure of the amount of matter in an object. In the lab, mass is measured using a balance. The symbol for mass is m, and its unit is kilograms, but it's often expressed in grams or milligrams. This tennis ball has a mass of 45.0 grams. No matter what planet it's on, its number of particles, and therefore its amount of matter, does not change. Its mass will always be 45.0 grams. Weight is the gravitational force with which a celestial body attracts an object towards its center. This force varies from one celestial body to another. The object's weight is different on Earth, on the Moon, or even on Jupiter. The more massive the celestial body, the greater the force applied to the object. In this picture, the weight of a tennis ball is represented by arrows pointing towards the center of the celestial body. The length of the arrows shows that the weight of the tennis ball is relatively small on the Moon, greater on Earth, and greater still on Jupiter. In the lab, weight is measured with a dynamometer. The symbol for weight is Fg, and its unit is the Newton, named after the scientist Isaac Newton. The mathematical relationship between mass and weight is as follows. Fg is equal to m times g, where Fg is the weight or gravitational force in newtons, m is the mass in kilograms, and g is the gravitational field intensity in newtons per kilogram. The value of g is unique to each celestial body. For example, the Earth's gravitational field intensity is 9.80665 newtons per kilogram, which is usually rounded to 9.81 newtons per kilogram. The Moon, which is much smaller than the Earth, has a g value of 1.62 newtons per kilogram. In our solar system, Jupiter is the planet with the highest g value of 24.79 newtons per kilogram. This is logical since it's the most massive planet in our solar system. Let's do an example. A box of books has a mass of 13.0 kilograms. What is its weight on Earth? First, we identify the data. The weight, Fg, is the unknown, and its value is in newtons. The mass of the box of books, m, is 13.0 kilograms, and we will use the Earth's value of g, which is 9.81 newtons per kilogram. Since Fg is equal to m times g, we can replace the variables in the formula with the known values. Thus, Fg is equal to 13.0 kilograms multiplied by 9.81 newtons per kilogram. The weight of this box of books on Earth is about 128 newtons. What is the weight of the same box of books on Jupiter? Once again, identify the data. The weight Fg is the unknown. Its value is in newtons. The mass of the box, m, is still 13.0 kilograms. And since it's now on Jupiter, the gravitational field intensity, g, is different. Here the value of g is equal to 24.79 newtons per kilogram. Since Fg is equal to m times g, we can replace the variables in the formula with the known values. Thus, Fg is equal to 13.0 kilograms multiplied by 24.79 newtons per kilogram. The weight of this box of books on Jupiter is about 322 newtons. We can see that the weight of the box of books is greater on Jupiter than on Earth. The result makes sense because the gravitational field intensity of Jupiter is greater than that of the Earth. But remember, the mass of the box of books remains the same at 13.0 kilograms. This is because the amount of matter that makes up the box of books does not vary, no matter which planet it's on. What if we had to find the mass of an object from its weight? What is the mass of a book whose weight is 4.9 newtons on Earth? The weight of the book, Fg, is 4.9 newtons. The mass, m, is the unknown, and its value in kilograms. The Earth's value of g is 9.81 newtons per kilogram. If Fg is equal to m times g, then m is equal to Fg divided by g. Let's substitute the data in the formula. M is equal to 4.9 newtons divided by 9.81 newtons per kilogram. The mass of the book is about 0.5 kilograms. In summary, mass refers to the amount of matter that makes up an object, and it's never influenced by the celestial body on which the object is located. Weight is the gravitational force exerted on an object that depends on the intensity of the gravitational field to which it is subjected. Mass and weight are mathematically related by the formula F equals m times g.